Process mining provides a powerful lens through which we can observe, analyze, and improve business operations. It acts as a bridge between data science and process science. In manufacturing, and especially in glass production, this technology is a transformative engine for operational excellence. Glass manufacturing is a process-centric industry. It involves a sequence of highly sensitive and energy-intensive stages: melting raw materials, annealing, final inspection. Each step presents opportunities for deviation, waste, and inefficiency. Traditional methods of analysis often fail to capture the end-to-end reality. They rely on aggregated data or manual observations that miss critical nuances. Celonis, as an execution management system powered by process mining, offers a direct view into how these processes actually run. It does not rely on idealized process models drawn on a whiteboard. Instead, it reconstructs the real process flows from the digital footprints left behind in systems. ERP SCADA. For a glass manufacturer, this means gaining unprecedented visibility into the entire production journey. We can see precisely how long each batch spends in the furnace, identify bottlenecks in the cutting line. For discovery, one would explain that this is the most fundamental type of process mining. We use event logs from the furnace's control system to automatically generate a process model. This model would reveal the actual sequence of operations: charging raw materials, the melting phase, refining, and finally, tapping the molten glass. It might uncover unexpected loops like repeated temperature adjustments or parallel activities that were not part of the official procedure, providing a pure, data-driven picture of what truly happens inside and around the furnace operations. Next, the candidate should address conformance checking. Here, we compare the discovered process model against a predefined ideal model. For the glass furnace, the ideal model might specify a precise temperature curve and duration for the melting phase to ensure optimal glass quality and energy efficiency. Conformance checking in Celonis would highlight any deviations. Finally, the explanation should cover enhancement. This type of process mining aims to improve the existing process model using data from the event log. The goal is to extend or refine the process model to make it more comprehensive. In our furnace example, we might enhance the model by overlaying contextual data: raw material composition for each batch, the specific operator on duty, external ambient temperatures. By doing this, we can analyze how these factors influence the process flow. For example, an enhanced model might reveal that a certain combination of raw materials consistently leads to a longer, more energy-intensive melting cycle. Interviewer question: imagine we are seeing frequent delays in our cut-to-size process. Write a PQL query to identify the average time between the annealing complete and cutting start events, and filter for cases that take more than 30 minutes. This question directly assesses a candidate's technical ability to use process query language, the core language of Celonis. A strong answer involves not only writing the correct code, but also briefly explaining its components. The candidate should demonstrate their ability to manipulate event log data and calculate cycle times. The query should be clean, efficient, and directly address the problem of identifying bottlenecks between two key stages in glass manufacturing. Here is an example of a robust PQL query to answer this question. This query calculates the throughput time between the end of annealing and the start of cutting. It then filters this result to show only the cases where this specific throughput time exceeds a threshold of 30 minutes, helping to isolate significant delays. Select case ID. Calculate the time difference between the two activities. Calc_. Throughput, case when activity equals sign, annealing complete, then event time end, case when activity equals sign, cutting start, then event time end. As annealing _ to _ cutting _ time from glass _ production _ log. The having clause filters the aggregated results. You are tasked with creating a dashboard for the quality control manager. What are the top 3 KPIs you would display for the glass inspection process, and how would you visualize them to make them actionable? First KPI, first pass yield, or FPY. FPI measures the percentage of glass sheets that pass final inspection on the first attempt without rework or scrap. Use a large gauge chart or single KPI tile showing current FPI versus a target, for example 95%. Second KPI, defect type Pareto analysis. It's not enough to know defects occur, the manager needs to know which types are most common. Bubbles, scratches, dimensional errors, stress fractures, Visualize with a Pareto chart, bars for frequency, and a line for cumulative percentage. Third KPI, rework rate and the rework loop. Rework rate reveals inefficiency even when FPY is tracked. Visualize with two connected components. First, a simple KPI tile showing the percentage of products that enter a rework cycle. Second, embed a simplified Celonis process map that highlights the rework loop. Ultimately, the true value of Celonis in a manufacturing environment lies in its ability to drive strategic initiatives and foster a culture of continuous improvement. The data and insights generated are not an end in themselves, they are the starting point for tangible actions that enhance efficiency, reduce costs, and improve product quality. A candidate who understands this strategic dimension can articulate a vision that goes beyond day-to-day monitoring. They can explain how process mining serves as a cornerstone for larger business objectives, such as achieving operational excellence, implementing Lean Six Sigma principles with greater precision, or enabling a more agile and responsive production system. This perspective is what truly differentiates a Celonis analyst from a process improvement leader. Mastering Celonis empowers roles within glass manufacturing by democratizing data and making complex processes transparent. For a production line manager, it replaces guesswork with evidence, allowing them to identify the root cause of a bottleneck in minutes rather than days. For a quality engineer, it provides a detailed case-by-case history of every defect, linking it back to specific machines, operators, or material batches. For a plant manager, it offers a holistic end-to-end view of the entire value chain, proving they are not just a data analyst, but a valuable partner in driving the future of manufacturing excellence.